Hello, everybody, and welcome to this webinar about the advantages of using high-pressure water mist and high-pressure pumps in fire suppression systems for data centers. I'm happy to see that so many of you have decided to join our session here today, and I hope you will find it very interesting. First of all, before we start out, there are just a few practicalities. First of all, you will be muted as default, but please, if you have any questions, do not hesitate to ask us using this Q&A option that you have on your screen. Also, this session here will be recorded, so you will have the option to watch it again later on or share it with a colleague, and we will be sharing the link to the recording shortly after we finish the session. Finally, there's also additional material that you are able to browse through, including animations as well. So please feel free to do so. All right, that was it for practicalities. Now let's move on to the actual content. So today's webinar is hosted by Danfoss High Pressure Pumps. We're making high pressure pumps and high pressure valves. We are a component supplier to the firefighting OEMs. We are two presenters today. There's myself, my name is Kent Mens, and I'm the product manager for the pumps and valves that are relevant in these applications that we're going to talk about. Besides this, we have my colleague Amin Hadian, who will start out talking about high pressure water mist and the use of high pressure pumps in data centers. But perhaps, I mean, you could just introduce yourself shortly.
Yeah. Thank you so much, Kent. Good morning, good afternoon, everybody, from wherever you are joining us. Thank you so much for your time. Today, I would try to go through some slides showing you the main components we are manufacturing at high pressure pumps and supplying to that industry. For sure, we are component sellers, we are component manufacturers, and our these components need to be integrated in a system and to be offered to that industry. So whatever we are speaking about, whatever we are explaining, should be considered as part of a high pressure water mist fire suppression system. When we talk about high pressure water mist in buildings, we not only are limited to the data center buildings, but also many other different applications or building types, as you can see here as an overview. Each building type has got its own particularities, its own risks, its own, let's say, special features that we need to pay attention to. But in the end of the day, all of them can be covered by a typical high-pressure water mist fire suppression system. But coming back to our main focus, which is data centers, the main issue or the biggest disaster is the outage in a data center. And all owners, operators just want to avoid this kind of outage because it means losing money. Definitely, because each outage brings some kind of impacts to the turnovers, and that's why they want to avoid that. As you can see here, there are independent institutes that collect all those informations and carry out surveys in order to understand which are the main causes for an outage in a data center. And here you can see that some of them are listed and collected. As you see, cooling, power, for example, or network, IT failures. And also you can see on the bottom right that they have also highlighted two issues. One is the fire, and the other one is fire suppression. So what does that mean? When we talk about the fire, which has here, according to their survey, about 3%, means that a fire has occurred and the existing fire suppression system, whatever it was, has extinguished the fire, suppressed the fire, and there have been damage, there have been outage, and this has been registered. That's one thing. But when we look at the fire suppression, which is 1%, this means that there was a fire over there, and there was a fire suppression system existing there, but it was not properly working. Means that the fire suppression might have failed and was not reliable enough. And this is a nightmare for a data center building, because you cannot predict all those following incidents which is connected to that. And that's why all the operators, all the designers, and all the owners just want to have a 100% reliable fire suppression system. One major thing, talking about the cooling and the power, when you have installed a high pressure water mist system in your data center, this is for sure an approved system. And when it is an approved system, then you can also be sure that these approvals have been done by running the ventilation inside the data center building, and also all the servers have been under power. So you don't need to shut off the electricity. All the servers can remain energized, and also the ventilation can continue working during you extinguish with high pressure water mist. This is a good advantage of this system that you have compared to some others to that I come later. And also you don't need to be worried about the failure discharge or the refilling efforts and costs, and the cleaning after that, which are also some major advantages of using a high pressure water mist system in your data center building. I just want to show you an overview about the existing extinguishing agents in general, not dependent on data center specifically. You can see in the first column, the left hand, the possible extinguishing agents in the world. It can be water-based, like water mist or sprinkler. It can be a foam system, can be a dry powder, or other chemical gases. And you can see on the first row on the top that we have different fire types, fire classes that are existing and could be existing in a data center building as well. And if you look at the matrix, and you can see that the only extinguishing agent which could cover the most of those fires is the water mist. For sure, there are also limitations, like you can see in the burning metals. We don't recommend to use water mist or water for those burning metals. But if you look at those remaining fire types, you can see that the application of the high pressure water mist is the best solution compared to the others. When you want to convert that to a data center building, it means that you can combine many different areas, many different risks with one unique system. But we come to that later. So the existing technologies for covering or protecting a data center building, they are a few actually. Yeah. So we have traditional sprinklers are being used since many years, started in North America, because sprinkler has a very high value over there, and there are existing systems, existing projects. Then we have also gas suppression system, are also one of the very frequently used systems inside the data center building. And then we have water mist systems, which I divided it into low pressure and high pressure water mist. Talking about the pressure, there are clear definitions in the standards documents and regulations. For example, in this case, in the National Fire Protection Association, they define the pressure range like you can see in this slide. Whatever up to 12.1 bar, it is defined as low pressure. From 12.1 bar to 34.5 bar, we talk about the medium pressure, and above 34.5 bar, it is defined as high pressure. So, and the area where our pumps are working is something around 120 bar. It can be lesser and it can be higher, but we talk about system pressure, internal pressure, not the pressure of water which comes out of the nozzle. So don't worry about that. And when we look at the droplet sizes and compare the technologies with each other, a sprinkler droplet diameter is has something around 1 to 1.2 millimeters each droplet diameter. The micron, 1000 micron, is equal to 1 millimeter. So when we put the water more under pressure and we come to the low pressure water mist level, we talk about droplet diameter of 0.2 to 0.7 millimeters. And when we push it farther under pressure and we come to the high pressure water mist level or range, then we have 0.04 millimeter to 0.1 millimeter for each droplet. So you can see the higher the pressure, the smaller the droplet size and the diameter. Why do we do that? For two major reasons. And these are the major effects of using high pressure water mist. The one is that you put the water under pressure and you make these small droplet sizes. These droplet sizes are distributed out of the nozzle head and they come around the fire source. As soon as they have reached the fire source, they vaporize, they change their condition from liquid to gas. And by this, they enlarge their volume up to 1,500-600 times more. And you create a layer of water steam. And this layer just lays like a blanket around the fire and you suffocate the fire. What does it mean? The oxygen cannot enter the fire source, so you suffocate the fire. And this effect is called oxygen displacement or inertizing. So that's one of the major effect that you have with the high pressure water mist. The next one is the cooling effect. What does it mean? Whenever you have the small droplet sizes of water mist around the fire source and the flames and temperatures reach those droplet sizes, they vaporize from water to steam, and this change of condition takes a lot of heat energy out of the fire. So at the fire source, you cool down or reduce the temperature enormously, and this is the second major effect of the high pressure water mist. So on the one hand, the inertizing or oxygen displacement; on the other side, the cooling effect. Coming to a typical data center building, as you can see in both pictures, a data center building is a complex building. You have got different types of areas and rooms, and each area has got its own risk. And what we want to show is that you can combine and connect, as previously said, all these areas into one unique high pressure water mist system. And the advantage is that you just don't have to design and plan and purchase different extinguishing systems. And if you look at the side view of a data center, in some projects you have also false floors or even false ceilings, and these areas are also part of the consideration when you design your system. So there are design differences and regulations that you have to follow, but everything within this building can be combined to one unique high pressure water mist system. I mentioned in the beginning that one of the conventional extinguishing systems for a data center is a gas suppression system. And I just want to go through that system, that technology, and later on to the sprinkler. For sure, a gas suppression system has got clear advantages. It is a well-known system since years and is being used, has the low ozone impact or lower greenhouse effect, and also the cleanup costs and post-discharge efforts are relatively small. But this gas suppression system have got also some disadvantages when you compare them to a high-pressure water mist system. First of all, you need to create all those rooms where you want to distribute the gas inside. You have to make them gas tight. You have to insulate them. You have to make them in such a way ready that the concentration of gas is remained in that room in order to extinguish the fire. Otherwise, the gas would flow away, and then you will never reach that minimum necessary concentration of the gas. In a high-pressure water mist design, you don't need that. The next one is that once you have distributed this gas agent into those rooms, you overpressurize the room. So in order to avoid any structural deformations, any damage of the building materials, you need to provide sufficient pressure release openings inside your construction. This is also an architectural compromise that you have to consider, which you don't need, again, by the high-pressure water mist system, because the water mist that comes out of the nozzle is atmospheric pressure, and you don't overpressurize those rooms. The next one, which is also shown and demonstrated in these rooms, is the space that you have to consider for all those cylinders and cylinder racks. If you have, for example, a building which goes above many levels, you might have allocated rooms and spaces for each level, and these are spaces that you could have used for something different. Yeah, so you could save money and use that for maybe additional server rack or some other applications. In a high-pressure water mist system, you have it possibly somewhere in the basement, and from there you connect this pump system through the pipes and then zone valves into different zones, and everything is localized in the basement. So, and the spaces and the dimensions that you consider for a high-pressure water mist pump system is by far smaller than a gas extinguishing system. And for sure, one of the major disadvantages that we see is that in many concepts of gas extinguishing system, you have to shut down the ventilation in order not to suck out the gas from the extinguishing rooms, and this is not necessary with the high pressure water mist system. So you can feel free to run to let the ventilation run during you are extinguishing any area in that building. And comparing to the sprinkler system, as I said, a sprinkler system is traditionally one of the well-known, worldwide recognized technology. It's being used in many projects, and they have good approvals, good standards in place, and the installation costs, equipment costs, they can be lower than high-pressure water mist system. But for sure, also a sprinkler system has got some disadvantages when you compare that to a high-pressure water mist system. First of all, you need much more water to extinguish the same fire compared to a high-pressure water mist. So if you use more water, you have also more water inside that room. So the damage occurred to the water distribution is by far higher. So all those cleaning up works and efforts, they are there. And then you have for sure also to allocate spaces for your pump systems, for your valves, and then for your installation equipment, which is by far bigger compared to a high-pressure water mist system. Then there are also the risk of having corrosion inside the pipes, because they are not using stainless steel pipes like which is the case in the high pressure water mist system. So in high pressure water mist system, all the parts in touch with water are made out stainless steel or corrosion-free materials, which is also a big advantage. I have spoken about the water damage. It is clear that a fire risk or a fire hazard which can be extinguished with less water. It is environmentally more friendly. It is money saving after the fire incident, and it needs less water reserves, smaller water tanks, and saving money on that side. And when we talk about the lower capex, as I said, for the same compartment with the same dimensions, you need less nozzles in the high pressure water mist, and in result less pipes and less materials and less installation costs compared to a sprinkler system. And this saves also a lot of money on the capex side. And then I come to my last slide. What I would like to explain here, this slide is dedicated to when we compare high pressure water mist to a gas suppression system, but more or less the same is the case also when you look at a sprinkler system. As an operator, as an investor, if you get a quotation for a gas suppression system for a data center, and you compare it to the same for with a high pressure water mist system, for sure, at the first glance, the quotation for high pressure water mist might be smaller. For the gas suppression system might be cheaper than a high pressure water mist. But the total cost of ownership is not only limited to the total investment. You also have operational expenses, running costs day by day. And you have also to consider all those hidden costs or the costs that you might have not seen in the beginning. Once you have purchased the gas extinguishing system and you have installed that, already in the design phase, you have to know, you have to consider conditions about the groundworks, about the trenches and pipes. You have to know that it is a high pressure agent, and then all those ceilings and making or insulating those rooms. These are these architectural efforts, those openings. As I said, these are all that you have, and you might have the initial testing, which is testing of those cylinders inside those rooms and the refilling costs. And once it's finished and then the system is commissioned and handed over to the operator, you will always have those regular gas distribution tests, and you need to make the cylinders empty and then refill that again. You have to consider the regular maintenance costs. For sure, we have also maintenance procedures for a high pressure water mist system, but this collected together with all those hidden costs in the installation phase and generation, it makes the thing much more expensive. And one major risk that you have is that the gas extinguishing system can only be activated, not only, but normally is activated through a detection system which is installed in that. So the detection system detects smoke, a flame, or heat, whatever the design is saying, and then sends the activation signal to the gas racks. And just imagine that if the detection system has a malfunction or gives a wrong signal, even if there is no fire or smoke inside it, then after maximum 1 minute, the gas extinguishing system is activated and the gas is released into those rooms. Nothing happens. There's no damage of fire or whatever, but you have to refill all those cylinders again, and then you have to clean up those areas. You have to stop the operation. You have an outage. And just imagine that some newspapers are mentioning that, yeah, the data center X had a failure due to extinguishing system. So the image losses could be a lot if you can imagine how sensitive this business is, and how many companies are trusting their data, their valuable data to these data center buildings, and no one wants to be put under the focus and light of those newspapers and get such bad and negative recommendations. So, having said this, I am at the end of my presentation, and I would like to hand over to my colleague Ken. Thank you, Ken.
Yeah, thank you very much, Min, for taking us through this part about the advantages of high pressure water mist. I would then go on, talk a little bit about our products. And at the heart of the high pressure water mist skids, we have the high pressure pump sitting. Our pump is called PAH. It's for drinking water, and it's a positive displacement pump. It means that the flow it provides is directly proportional to the speed. So the higher the rotation, the more flow it provides. It's made of stainless steel, and it makes it highly reliable. This is, of course, key in firefighting applications, that whenever there's a fire, it simply must start. Right. Also, there's no oil inside the pump. It means that the pump is being lubricated by the media itself. This also makes service and maintenance very easy. And you don't have to, of course, make any oil change. They come in various sizes, as you can see here in the table below, fitting to the different needs of the applications here. The larger pumps we have are the ones that are mainly used for, or as a main pump in a firefighting skid. As you can see here, under normal operation, they go up to about 147 liters a minute, but they can be also overspeeded and provide up to 187 liters a minute. At the other end of the spectrum, our smaller pumps, they are mainly being used for jockey pump or pilot pump functions whenever that is being used. The jockey pump function ensures that there is a constant system pressure in the system, also when the system is not activated. And they can be installed in both a horizontal and vertical installation. Yeah, one of the things that we have added, as you can also have a look at in this document or download section on your screen, is a 3D model of our pumps, which you can open up, and then you can have a look, turn it around, see how the pump actually looks. So feel free to do that. Besides the pump, we also have a number of various high pressure valves. On top, you see our directional solenoid valves. That's an open-close valve. It's being activated by the coil sitting on top. That's the blue part. You can see they are also made of stainless steel, and they come in various sizes up to 150 liters a minute, and they come in various types, both as single valves and as block valves, where you have more valves sitting in one block. On the picture what you see here, that valve is a valve with a manual bypass, meaning that you can both activate it using the coil, an electrical signal to the coil, or you can manually open the valve with this small handle you see. All right, below this we have our relief valve and our check valves. They are also both made out of stainless steel, making them very reliable and durable. These are, both of them also come in various sizes to fit whatever flow is generated in the system or by the pump. Right. So the function of the relief valve is to protect the system from being over pressurized. Whenever the pressure is above a certain level, the relief valve will open and relieve any excess flow and pressure to a drain or back to a tank. And then the last valve we have, as mentioned, that's the check valve. It's used to make sure that there is no backflow into the pump. So it's sitting on the high pressure side of the system and protecting the pump, basically. Right. So to sum it up, if we have a look on the pumps first, as mentioned, they're made out of stainless steel, making them highly reliable. The pump is very compact, making it easy to install also in tight spaces. And as mentioned, you can do that in both horizontal and vertical. The frame sizes that we have fit well to the applications and the flows needed. They are all lubricated by the media itself and only consist of few parts. So maintenance is very easy and fast to do. Due to the high number of pistons inside, the pulsations are very low and there's no need for pulsation dampeners also. In fact, the whole installation is quite simple. It just consists of an electric motor, a coupling and a bell housing, and then directly mounted with a pump. And finally, these pumps have a very high efficiency, and especially here when we are talking about firefighting systems, the size of the emergency generators is important. On the other side of the slide, we have our valves. As mentioned, they are all made out of stainless steel, making them highly reliable. They're very compact, so again, very easy to install in tight spaces in your installation. Furthermore, our solenoid valves, they can be serviced while they're sitting still in the pipeline. There's no need to demount them for making service. So again, very, very easy and service friendly. Furthermore, they also have a very low pressure drop, so providing a high flow, even though they're compact, with a low pressure drop. So that's just trying to sum up some of the benefits of the products that we offer for this type of application. Let's see if there are any questions coming in. I can see that at least there are some.
Yes,
So yeah. There is one here.
If you want to start, you can start, and I go for the next one. No problem.
Yeah, but I think the first one is perhaps for you, Amin. It says, can the water damage the servers? What happens when water and the electronics?
It's a very good question and frequently asked question, because yes, somebody who is working the data center environment and thinks about all those servers and all those electrical equipment and then looks at the water, it say, okay, these two things can never work. First of all, I can answer it with the words that there are even sprinkler systems that are approved for being used in that environment. So, and the sprinkler system has got much more water when they want to extinguish a fire compared to a high pressure water mist. So also there, they have carried out their tests without having any impact to the running electrical equipment. This is one approach or one way to explain that. The other way is that if you, for example, have your laptop open and you are sitting in outdoor and suddenly it starts raining, so you will never have any impact or explosion, because it is the water cannot damage or bring that kind of electrical shortcuts or whatever. So it's not damaging your equipment. This is one thing. The second thing is that whenever you have a fire inside those data centers, you are not bringing the water to everywhere within that room. You are just trying to bring the water or the water mist only around surrounding that area where you have the server on the fire, and not for the other, because all the other nozzle heads, they are closed. Whereas if you have an extinguishing system with gas, you have to bring the whole gas in the same time in the whole room. Yeah. And well, gas is not harmful to the electrical equipment, but just in the comparison to the amount that extinguishing medium that comes down. So you will never ever have that amount of water coming out. So it's not damaging your electronics inside that room.
Thanks, Amin. We also have a question about the pipe size. What pipe sizes do you normally need for high pressure water mist systems?
Yeah. Shall I
answer that?
Say something?
Yeah.
About it? Yeah. Very good. Very good question. Again, if you are familiar with the sprinkler system, you know that you need big sizes, especially depending on the size of your building. In the beginning, you need larger sizes of pipes, like 6-inch, 8-inch possibly, and you bring it to the zones, and then you become smaller the more you reach the end of your area. In the high pressure water mist, as far as I have seen it in the projects, the biggest pipe size or risers, even in a high-rise building, it was something around 3-inch, and then you go down to other sizes and smaller sizes. So you have an advantage of space saving compared to a sprinkler system, and you can let your pipe routes run through those installation shafts very easily, and that's a clear advantage on the installation side. Yeah.
Right. Thank you. Then we have a question about how many working hours the pump has in between the maintenance or service. Well, I can take that. Our standard time in between inspections is 8,000 hours. So that's the standard. Then we have some, for instance, when we are overspeeding the pump, which I mentioned in my part of the presentation, to make it provide even more flow. In that case, we have a recommendation saying 500 hours in between service. 500 hours is usually more than enough when we're talking about firefighting systems. So it depends what mode you run the pump in. Right. Then there is a question about this system of high pressure water mist requires, or does it require an annual test to avoid any obstruction for inactivity?
And as the water requires additional chemicals for maintenance, maybe you can say something about the regular tests of the pump itself that we require as component seller.
Yeah, but I know that there are regular test runs that to check that the system is still working and that the pump starts and so on. So that there is on a regular basis in these
and the system integrators they have to follow that. Those who just integrate the pump in their pump unit and let's say make the complete pump system, they have to obey those regulations and those regular tests, I believe, which is highlighted in the related documents.
Exactly.
Yes. And the next question was, the water requires additional chemicals for maintenance. I don't think so.
No.
There is no need for it. Yeah. So what was the next question?
Then there is somebody's. Yeah. Okay. Yeah. There was also a comment or a question if we are sharing, if it's the presentation and the recording here, then that is meant. Then yes, we are going to share that afterwards.
Yeah.
And are there any problems with the oxygen level in the room once the system has released or been activated? I mean, for human beings. I think this is related to this blocking of oxygen you talked about. I mean,
yes, exactly. What we are talking about is happening. I mean, with the oxygen displacement or oxygen reduction, we talk about the fire source and fire surrounding, not about the whole room. Again, you have the ventilation running into that room, so air is coming and going out. You have all the servers are running in that area. You just imagine a big white space, how they call it in the server rooms, in the data centers. So you have several rows of racks and so on, and just at the corner or somewhere, the fire has occurred, and the glass bulb above the burning server has broken, and the water mist is distributing out. So in all other adjacent areas and remaining areas, they have no impact, neither about the water damage or water, nor about the oxygen reduction. So to answer that question clearly, it's not any impact to human beings, so that the oxygen level is so reduced that you cannot breathe. But like all other fire safety regulations, also in the high pressure water mist, it is recommended, or it is just even said that as soon as you know that a fire has occurred, with all those signals, you have to leave those rooms and evacuate in order to keep yourself in a safe area.
Thanks. I think the next one is more of it's just a comment, I think, that typically when a fire is detected, the power is disconnected for safety reasons. And therefore servers are powered off, meaning that they're safe and no effect to the servers.
Yeah. This can be the case that it is related to their data center internal rules or whatever they try to do. What we try to say is that when a high pressure water mist system is activated and it's working, it is not requested by the extinguishing system that those servers are switched off and the electricity is powered off. That's what we say. But if their procedure, their regulation requires that to do that because they just want to avoid any risk, then this is something different. But that's the case that also I know it, that those approved high pressure water mist suppression systems, they in their test procedures for the approvals, they said that or the approval test procedure says that the electrical servers, the electricity doesn't need or doesn't have to be switched off. Yeah.
All right. Then we have one more question here about, I mentioned this, that the standard is 8,000 hours, but we have some cases, for instance, where we overspeed the pump, and in that case, we're talking about 500 hours. And then the comment is that it seems like a big jump. For sure, that when you overspeed the pump from the maximum 1800 RPM, where we say 8,000 hours in between service, and then say if you speed it up to 2400 RPM, which is the maximum, in that area where we are saying 500 hours. And yes, you are right. It's because we have tested in 2 points. And this is something that I know has also been addressed by your company, that this is something we could look at, what we actually can say to avoid this big jump, but more a line in between. So it's not just directly jumping from 8,000 hours. This is something that we have it on our radar. But thanks for the question, and you are right. Okay, are there any more? Yeah, there's a question here about minimum discharge pressures in regards to jockey pumps, right? So here we are talking about our smallest pumps. Maybe I can just jump to the slide here. Typically, one of the 2 pump frames that we have on the left side of the table here. We are right now actually very close to implement that our pumps, we have tested them and they can go down to 10 bar discharge. So this is one of the newest things that we have been working on, and that will come and be released very soon, within weeks. So that's actually that question is actually fitting quite well. So the pump will be even better able to handle these jockey pump functions. Right. There's a question about the orientation of the pump as well. They can be installed both in a vertical or in a horizontal orientation. So that's depending on your application, what you need, and how much space you have. Then I know there was actually there was a question in our live session yesterday about certifications and approvals and such. As mentioned here in this slide, for the pumps and our VDHT valves, we do offer marine certification So it could be like RINA, DNV, ABS, and that sort of thing that we can do. It's not directly related to data centers, I know. Then you can say, when we're talking about other firefighting related certifications, they are mostly, when we're talking about high pressure water mist, on a system level. So they are not on each single component as such. It's a complete system certification. We can, however, of course, for the sake of our pumps and so on, and do that, we provide the documentation that is needed to support such a certification. Could be like FM or the German VDHT, that sort of thing. But it is a task that is being handled by the firefighting OEMs, and then we support it. All right. I don't see any more questions
left
at this point.
Yeah.
And if not, you're of course always welcome to reach out to us if you have questions coming up later. We'd be happy to answer them at that point then.
And I think we will have a recorded version of that, right?
Yes, there will be a recorded version that will be shared with you. Shortly after this session here. So you are able to watch it again or share it with a colleague if that's what you would like. All right. I mean, as I don't see any more questions, I think we should say goodbye. And I hope you have enjoyed this session. As said, please feel free to reach out to us in case you have more questions coming up.
Thank you also from my side for your time and for your attention. Have a good day.
Yeah, have a good day.